In this video, we are going to see about the scatter plot for a quantitative variable. An effective way to see a relationship in a data is to display the information as a scatter plot. It shows how two variables, the explanatory variable and the response variable x and y, relate to each other by showing how closely the data points fit the line called the line of best fit. So let's see what is the scatter plot and what is the line of best fit. So the main objective of this video is to have a bivariate data and draw a scatter plot for the bivariate data, interpret those scatter plots, and also to add variables to those scatter plots. A scatter plot is used to display quantitative bivariate data. That is, it displays the variables x and y. The x variable is the explanatory variable or the independent variable, and the y variable is the response variable or the dependent variable. So we take the explanatory variable on the x-axis and the response variable on the y-axis and draw or get the scatter plot. To understand the scatter plot, let us take an example. In this example, the local ice cream shopkeeper tracks how much ice cream he sells during the noon temperature. So he has x to represent the temperature and y, which is the predicted value, the response variable, as the ice cream sales. So keeping y as the ice cream sales and the temperature x as the explanatory variable, let us draw the scatter plot. So when we draw the scatter plot, by taking the temperature on the x-axis and the response variable on the y-axis, we get the points scattered all over. The points do not lie on a straight line, they are scattered all over. So that's the reason why it is called scatter plot. So for 12 degree, the sales was around 200. So you can easily get the scatter plot using the temperature as the x-axis and y variable as the sales. Now, in order to interpret the scatter plot, after plotting two variables on a scatter plot, we describe the overall pattern of the relationship based on the form of it, or the direction, the strength, and also the outlier. When we talk about the form, you can have linear scatter plots, curved, clustered, or no pattern at all. We can also talk about the direction, whether it is in the positive direction, negative direction, or no direction at all. The strength, how closely the points are connected, or how the values are deviated from that pattern. And we can also check whether it has an outlier for this relationship or not. Now, in the first diagram, it looks like the points are almost close to a line. So since these points are all close to a line, there is a linear relationship. And in this case, the points are scattered all over. So we are not able to predict a line here. So it has a weak relationship, or we can say it has no relationship at all. In a third diagram, it looks like the points lie on a curve, like a parabola. So it is non-linear relationship. In my first diagram, it looks like the points are almost close to a line which has a positive slope. So it is positively associated. As x increases, our y also increases. So it is positively associated. In our second diagram, as x increases, y decreases. That means these points are almost lying on a line. We can represent a line with a negative slope. So it is negatively associated. The direction of this is negative. So in the first diagram, though these points do not lie on a line, but still we find that these points are almost lying on the line. So it has a strong negative relationship because the slope of that line may be negative. Whereas in this case, though the slope is negative, the points are a little further away from the line, so it has a weak negative relationship. Now in this case, we can talk about the outlier. If an outlier is a data value that has a very low probability of occurrence, that is, it is unusual or unexpected. In a scatter plot, outliers are points that fall outside of the overall pattern of the relationship. So when I talk about points here, maybe this point may be taken as an outlier because for the rest of the points we may find a line of best fit, something like this. So if I want to draw the line of best fit for my previous one where the temperature and sales of ice cream were provided, by freehand method I can construct a line such that approximately equal number of points lie above and below. So this is the line as close as possible to all points and as many points above the line as below. And this line is called the line of best fit or the least square regression line. But for better accuracy, we can calculate the line of best fit using our graphing calculator. So by drawing this line of best fit, we can predict the value which lies between say 20 to 22, because though the value between 20 to 22 is not given in our original data, we can find the value, the sales for when the temperature was 21 degrees. So we are trying to interpolate the value. Interpolation is where we find a value inside our set of data points. The same way, we can also find this value for the set outside the given data points. That is, say for 29 degrees, we can find the approximate sales as 740 using the line of best fit. So this method is called the extrapolation. Extrapolation is where we find a value outside our set of data points. So the line of best fit is helpful to us to find the interpolation and extrapolation. So this video helped us to understand what the scatter plot is and how to get a line of best fit using a freehand method, and how the line of best fit was useful to predict the relationship between the two variables, the explanatory variable and the response variable y. So this video helped us to understand the relationship between the two variables using the line of best fit and the scatter plots. Hope this video was helpful. Thank you for listening and thank you for watching.